Okay, so we have the velocity. I'm going to copy it so I can put this away. So this was g. So one more time, the velocity equals pi over 2 cosine pi t over 2. So was this clear with 1 foot this way, 2 this way, 2 this way, and 1 this way? Is that okay, everyone on this? Yes, anyone? Okay. Good, so this was the velocity. Now we're asked to find the acceleration. I have to copy pi over 2, but now I have to differentiate this, which is negative sine pi t over 2 times the inner function prime. So then I have negative in front, pi squared over 4 times sine pi t over 2. Now they're asking us to find a of 1. So sine pi over 2, anyone remembers how much is sine pi over 2? Yes. So 1 times negative pi squared over 4 is negative pi squared over 4. Can anyone give us the measurement unit for the acceleration?
Meter per second squared.
Thank you very much. This was g. H, we can graph with the graphing calculator, of course. It will take us forever to do it by hand. Okay, final question here. Finally, we got to the last one. I, when is the particle speeding up and when is it slowing down? Speeding up, slowing down. That's why, and I hope, so here's going to be conclusion. I have to find the so-called zeros for this function now. Why? Because as we discussed, if both go in the same direction, positive direction, negative direction, then the particle will be speeding up. But if they are going against each other, if both are positive, it's speeding up. If both are negative, it's speeding up, so on and so forth. But if this is positive and this is negative, I'll have to write slowing down. If this is negative and this is positive, I have to write slowing down. So I will not be able to draw a conclusion before I study in the same way I did for velocity. I start the discuss or study the acceleration. So we need the zeros and then the sign, exactly what we did for velocity. So I'm going to have sine, because with negative this is a constant, sine pi t over 2 being 0 on the interval 0.6 seconds. So now I'm looking at the unit circle where sine is 0. So then pi t over 2 could be 0, could be pi, could be 2 pi, could be 3 pi, could be 4 pi. We'll see if this is enough. If it exceeds 6, then I'll drop it. If it does not, I still have to continue. So from here, t must be 0. From here, pi t over 2 equals pi. Can anyone give us t? Simplify by pi, and we get what? Anyone? 2. Very good. So pi t over 2 equals 2 pi. So t equals
4.
Excellent. Still not. Okay. Pi t over 2.
6.
Very good. So this is not needed. It's beyond 6 seconds. Now, go back to my table, and I will put 0, 0, 2, 0, 4, 0, and 6, 0. Now I'm going to put this function in the graphing calculator, and I will plug in 1, I will plug in 3, I will plug in 5. I only need the sign. So I will share my screen, put in the third function, or delete, it doesn't matter, it's the last. You can delete everything now, it doesn't matter. But lazy people, this is how they do it. Okay, put parentheses and put in front negative pi squared divided by, I need a parenthesis, I need an extra parenthesis here. Divided by, yeah, I knew that was going to happen. Never mind. You have to put insert several times so you don't miss that. Okay, so it's okay. Not a big deal. Pi squared divided by, and we had 4, close the parenthesis, and then we have sine, and we have pi, and we have x, and divided by 2, and close. I'm checking, so negative pi squared over 4, correct? Sine pi t over 2, perfect. So now all I want is 1, 3, and 5. 1, 3, and 5. So at 1 is negative, at 3 is positive, and at 5 is negative. I put the signs in, and now we have to draw a conclusion. What does the particle do between 0 seconds and 1 second? What do I write?
Slows down.
Yes, slowing down. What does the particle do between 1 and 2?
Speeds up.
Yes. What does the particle do between 2 and 3?
Slows down.
Perfect. What does the particle do between 3 and 4?
Slows down. Speeds up.
Yes.
Speeds up.
Good. What about between 4 and 5?
Slows down.
Good. And finally, between 5 and 6.
Speeds up.
That's it. These two forces, the velocity and acceleration, are not working together. They're working against each other. Here, they are working together. So what? In a negative direction. That's fine. But they're working together. Here, they're head-to-head again, slowing down. Here, they're working together. The same positive direction this time. Here, they're working against each other. Here, they're working together. It was a very good pick. Much better than picking a polynomial function. Very good job. Okay, so let's also look at one other example or two, and then we can move on. Okay, so give me 1 second to plug in this laptop. Good. Okay, so we looked at graphs. We looked at that long thing. What about what is the velocity after 2 seconds? What is the velocity like? Yeah, we can look at this. At what time then does the particle have a velocity of 20? At what time is the acceleration 0? So if you'd like, we can look at one of these. We all know all this. This is the same thing over again. We've done this in chapter 2. All these are the same idea, rate of change. This I like. If a cylindrical cylinder, such and such, find the rate at which water is draining from the tank after this and that. And I think that should do it. These are just differentiation for chemistry and other things, but I'm happy with just simple applications of differentiation. Okay, so let's choose at least one more or just one more, whatever you decide, and let's move on. Do you want the distance, the particle? Do you want the cylinder, what was it, the cylindrical water tank? Which one? Let's choose one.
Can we do the cylindrical?
Yes, yes, let's do the cylindrical. Very good. Good. I'm on page 7. Okay. So the water drains. When we say that the water drains, it means that the rate of change is negative. Okay, the rate of change is negative because the volume decreases from the bottom of the tank in 40 minutes. So this is 20 in 3.7, and we have time 40 minutes to empty. Then Torricelli's law gives the volume V of water remaining in the tank after t minutes. So it's V of t then, 5,000, 1 minus 1 over 40 t squared, of course, for t between 0 and 40, clearly. At what rate, find the rate at which water is draining from the tank after 5, 10, 20, and 40. So 5, 10, 20, and 40 minutes. And then at what time is the water flowing out the fastest? The slowest, summarize. Fine. Fastest, slowest, and we'll present the table. Good. Perfect. Just a wild guess. When do you think is the fastest? And when do you think is the slowest? So let's suppose I have a balloon and I puncture it. When will the air go out the fastest out of the balloon? At the beginning. When will be the slowest possible rate of change of the volume with respect to time, the air coming out?
When it's almost empty.
Exactly. 40 minutes. Absolutely. Good. Okay, so let's illustrate that. We already know what to expect. So let's find V prime of t. This is the rate of change. Okay, of water with respect to time, of the volume of water with respect to time. Let me write that. Rate of change of the volume with respect to time. Okay, so V prime of t. Can anyone help with V prime of t? What?
10,000.
10,000, very good, times 1 minus, yes,
yeah.
to which power?
1.
Times the inner function prime.
-1 over 40.
Excellent, brilliant, thank you very much. So then this becomes, I'll put it here, I'll simplify as 0. 1,000 divided by 2 is 500, divided by 2 more, -250. 1 minus 1 over 40 t. That's it. T, 0, 5, 10, 20, 40, v prime of t. That's it. We'll plug it in. So in y equals, clear everything, -250, parentheses, 1 minus, don't forget parentheses here, 1 divided by 40, close, x, and close. And now we want 0 is right there, 5, 10, 20, 40. Good. So -250, -218.8. I don't need too much. 187.5, 125, and 0. Can anyone give us the measurement unit of this? Because all these are, so of course this is the max, the fastest, slowest. As expected, we already knew that. But my question is, what is the measurement unit? So let's look again. Velocity is measured in gallons. I'm sorry, volume is, I meant to say, not velocity. A volume is measured in gallons and time in minutes. So what is the measurement unit for v prime of t?
Gallons per minute.
Very good. Very good.